Good afternoon, everyone. Thanks for joining us. It's a beautiful afternoon. I know you have a lot of things to do. Of all the things that you share with us, your time is the most valuable thing that we can cherish. So we appreciate you sharing with us. My name is Sundar Raghavan, and I've been talking to some of our engineers. And in case you didn't know, in the language I speak, it means handsome. So I thought my engineers are being nice to me when they call me handsome. Turns out that they have a great sense of humor. They are the smart ones, and by definition, I'm not the smart one. So, and then, of course, I talked to Neil. Neil said, well, do you know what it means? Neil is our business development manager. Neil means apparently get rich. So with that stated, I have the pleasure of bringing two engineers, two fantastic customers on stage to share their experience with us. My goal is to try and share with you what we have done from a technology perspective to help you build great applications. One of the things that we realized at Amazon early on is really customers, when it comes to building applications, they prefer choice. Till this day, the technology choice that's been available to you is to use relational databases, and that works great. If you wanted to build scalable relational applications, we give you a platform, which is the Relational Database as a Service, and ElastiCache that goes along with it. We also recognize a lot of, and that's part of our SQL movement. That's right. Soon you guys know now what's coming next. A lot of you have said, well, I don't like SQL, and that's part of our NoSQL movement. And those of you who are building applications that are really massive scale, particularly web scaling, front-end facing, customer-centric applications, you could build them in a non-SQL way, in a very scalable way. Our goal is not to try and say one is better than the other. We will let your application choice make that to be whatever it is you need it to be. But our goal is to deliver you the service that you can count on, you can rely on, continue to innovate, and make it scalable, low cost, and effective. In the first part of the conversation, I plan to focus on the green side of the equation. We'll talk about what we have done from a scalability perspective, how you can take advantage of it. And then we'll also hear a case study from Flipboard, Greg Scallon. After that, we'll talk about DynamoDB, and then have a case study on how Earth Networks is making use of it to build a scalable application. The thing that I hear the most from our customers is the way people have built database applications the old way up until today, or up until now, is to primarily focus on scaling with a human intervention. So initially, the application starts fine. So you have the compute and storage infrastructure. Then as the application scales, you are now adding more capacity from buying boxes, buying storage arrays, and hooking them together. The problem is, as your application goes through its peaks and valleys, depending on the seasonality of your application or the nature of your application, you are continuing to add more and more capacity from a physical infrastructure perspective. And as you provision for peak capacity, you are stuck with that peak capacity. So really, the old way is to try and do this either in an optimistic way or in a reactive way, but do always with humans. So you have an army of boxes, you have an army of storage arrays, and then you have an army of people that are managing all of this. It gets very static. It becomes very cumbersome. In fact, when we speak to a lot of innovative companies, many of you in the room, what we consistently hear from customers is the time they spend on managing these server infrastructure, storage infrastructure, backup and recovery often far exceeds the amount of time they have to innovate. Much of the innovation is somewhere between 30 to 40% in actually scripting and coding and building application and performance optimizing, whereas a lot of the time is spent on database management. What our goal at the Amazon RDS team is to really try and help you make that 40% more like 100% of your time so that you can offload the remaining management tasks to the AWS engine. And that's what we have done. In the new way, what you can do with the RDS engine is taking that exact same application profile, but use your application to intelligently determine what's going on with the database engine, database layer, and accordingly scale it. For example, you can add compute, you can add storage programmatically, you can add instances, you can delete instances programmatically, you can switch from single availability zone deployment to multiple availability zone deployment programmatically through our APIs. That way, as you reach the peak, your application, through its intelligence, through the application logic that you have put in, is dynamically and very optimistically managing your capacity. And as your application goes to a lower end, you can now have a database that contains all the data possibly managed by an instance that's smaller than what you started with based on your application profile. This is very different than what we have thought about as databases. In the past, we have thought about databases as these untouchable entities where they have to always run and you cannot reboot a database instance. Whereas what we are suggesting here is you can make it very elastic. It's OK to drive database instances by the app. You can add capacity. You can add storage. You can do these things programmatically. The best part of all of this is the results are immediate. You don't have to wait for someone in IT to approve adding capacity to your box, or you don't have to wait for boxes to show up and cut and open and so on and so forth. You free up time that allows you to build scalable applications. That's what the database RDS engine is. We provide you a choice of database engines. You can use MySQL if you're very familiar with MySQL. And some of you may be building applications for enterprise customers that expect you to build it on top of a commercial database engine. Say, for example, Oracle. We fully support Oracle as a managed service as well. What we mean by managed service is you can literally go to the console, start a new database engine, and it'll be up and running, fully booted up and ready to go in a matter of minutes. You can use the scale compute operation to change the size and shape of that machine from small all the way to 4XL. Through your own architecture, you can partition and scale out as you choose to do. That's what we mean by push-button scalability. We do automatic backups. So pretty much every night, we take care of backing up your database. You can do a point-in-time restore very quickly. If you choose to, you can also initiate a point-in-time, a snapshot at any time of your choosing. So middle of the day, if you feel like you need to have a most accurate copy of your database, you can do that programmatically or through the console. All these services, the database services, they work together with everything else you have on the AWS platform. It works with EC2. It works with ElastiCache. You can connect it with other engines. So pretty much your front-end layer, the application layer, can be on EC2, and your database is fully managed and ready to go. Oftentimes, I get asked by people, how do I make my database applications perform really well? There are lots of different questions that come up. First and foremost, people talk about availability as a requirement. Then they talk about increasing the throughput as a requirement. And then they talk about reducing latency. Typically, when I talk to customers, they've had to have independent projects in terms of increasing reliability or increasing throughput. So these are independent choices that they have been able to make in the old way. In the new way, the Amazon RDS way, these are choices that are available to you that you can mix and match. For example, if you build the application and you go through the development and test cycle and you are now ready to launch, you can push a button and basically make that deployment multi-AZ ready. When you do that, we'll talk a little bit more detail about that, your application will, your database will simultaneously operate in 2 different availability zones within a region and be durable and reliable. As you do that, you can also increase your read scalability to both instances by adding a read replica. We'll talk about what that means in a moment. You can also put an ElastiCache in front of them so that your application performance is highly optimized. These choices are available to you so that you can mix and match and define the perfect application characteristics that you're choosing. The best part is you don't have to really spend a whole lot of time. These are either console UI operation or a simple API operation. Looking at push button scaling, you can do scale in 2 dimensions with RDS. One, any instance that you start with the database can be scaled up. By that, I mean you can actually take that from small to medium to large to extra large, quadruple extra large. As you do that, you may also find out that your application is growing at a really faster pace than a single instance can handle. Through your application architecture, you can scale out. You can create partitions of data either on a vertical basis or on a horizontal basis across different engines and have your application intelligently go after the right partition for the right queries. The nice thing is, as you do this as part of RDS, all those shards are automatically backed up, and at any point with a simple push button, you can easily restore them as you choose to. And those snapshots are also available for you on S3 as an object. In addition to that part of scaling we talked about, the nice thing that you can do for your end users is, given most of the applications have more reads than writes, you can improve the readability of your application by putting in a read replica that goes with it. You can also use the read replica for business intelligence reporting, so your production server does not have to take the DSS queries that will come through your BI tools. And that operation is quite literally a simple console operation as well. The difference between our multi-AZ functionality and this read scaling is the read scaling read replica uses the native MySQL operation, so that the copies are pretty much, the read replicas are using the MySQL native operation. The thing that we all have to prepare for is, as Werner was saying, we cannot assume why things fail, or we cannot assume things will not fail. We have to assume everything will fail pretty much any time that you don't expect it to. The chaos monkey always rules, right, in our business. So if you have to prepare for redundancy in the past, the typical expensive path has been to try and do that yourselves by creating an alternate infrastructure. With our service, we provide you an enterprise-grade fault tolerance through our multi-AZ capability. What happens with this is, when you launch an instance and you say, I want to make this multi-AZ, behind the scenes, RDS service provisions and creates another copy, exact copy of that running in parallel. Your primary is always kept in sync with secondary through a synchronous replication technology. When there is a failure on primary for whatever reason, whether it's instance failure, storage failure, network failure, the system automatically detects it and allows you to do a failover. Upon failover, we also take care of reestablishing the secondary. Now that the secondary has become the primary, reestablishing the secondary so that you always have both copies all available and running in sync. This is a pretty important technology. It's a very cost-effective technology that you can use for making sure your applications are not only highly scalable, but highly reliable as well. The Amazon RDS technology, it's not something that is new. It's been in production for close to 2 years now. Thousands of users, hundreds of companies are using it every single day. In fact, some of the world's largest applications, such as TweetDeck or Gumi, which is a very large video gaming company, or Sega, they all use this. One of the most innovative companies that I've come across, in fact, my wife uses it all the time, is Flipboard. They are what the magazines of tomorrow, or a newspaper of tomorrow, from what I can tell. They have a very interesting, very cool application. How they built their application on top of RDS is a pretty unique story. I'd like to invite Greg Scallon from Flipboard to describe that story. Greg?
Thanks, Sundar. Hi, everyone. My name is Greg Scallon. I'm here from Flipboard, and my goal today is to describe to you some of the challenges that come with making decisions on how to store your data when you decide to build an application that has various requirements. With Flipboard, we started the company in January of 2010, and we wanted to release a product fairly quickly, and we came out with the first release of it in July of 2010, so after about 6 months. And we went from a very fuzzy description of what we were trying to do and what we thought our users wanted to a shipping working application. And this product really didn't look what it looked like the day we shipped it until about, I'd say, 9 days before we actually shipped it. So we had a lot of changes on the user interface from our developers as we were constantly changing things around. What this required of us was to think about what is the data that we need in the application and how do we ensure that it will scale regardless of what the usage will be when we finally ship the product. And because we didn't know what the product was going to look like or what data we needed, because we really didn't know what the user interface was going to look like, we needed elasticity. We needed the ability to constantly change where we were storing our data, how we were accessing it, how we were going to query it, and how we were going to operate on it and modify it. So one of the things that we had to build into this architecture was the ability to do very complex operations and to change what those complex operations are fairly quickly within the product. After we launched today, we've grown to about 5 million users and about 2 billion page flips per month. And in our product, the page flip is essentially, it could be several articles that you quickly see and that you flip through visually. So in order to do these complex queries in order to enable us to do these complex queries, we decided to go with RDS as our main database solution for the real-time queries that come from end users. So if it's a query that's going to come from an end user, and it may be complex or it may be simple, but it has to be responsive very quickly, we decided to go with RDS because we felt like it was a known solution that we can work with over time that would not run into a variety of other pitfalls that other database solutions might happen with you. So the general architecture of Flipboard service is a very similar n-tier application. It's you got your logic tier, and then you got your data tier. But within the data tier, we have many different databases. RDS is just one of them. We heavily use memcached within our product. We got, I think, maybe 700 gigabytes of memcache right now, and it pretty much grows every day. And one of our theories with memcached is if you're ever going to make a query twice and get the same results, stick it in memcached, whatever it is. Offload your queries from your database, because given the type of social application we are, where you're building highly relevant data based on what people are doing, what their friends are doing, and that they care about what's happened in the last few minutes in real time, you're doing a ton of writes to these databases so that when that user does come in, they have that information readily accessible to them at that moment, which means you have to minimize everything else you do in those databases. So we went through the architectural approach of just memcache everything as often as you can, and then your databases will have a lot more life to work off of. In addition to that, there's a lot of processing that occurs in the background. Since we're a social magazine, we do a lot of content processing. We're looking at web pages, we're analyzing, we're doing topic extraction, categorization. When your friends and your social networks that you've signed us up with are looking at stuff and they're sharing stuff with you and you're commenting on it with them, we're looking to see what it is about that information that you care about so that we can provide you with more relevant articles that you would care about. All this is happening in the background for us using a NoSQL solution because of the massive scalability that we need for that architecture. But in the end, what it's going to do is produce some numbers, some pieces of information that are going to go into this RDS database that we're going to make available to those real-time requests to ensure that we can deliver those features in a timely manner. So you can see that we have an ElastiCache type front end for all this data, which fronts MySQL on the back end. The SimpleDB is something that is a I consider a precursor to DynamoDB, but it's what we use for all of our operational stuff. One of the perks that we found of using that, for instance, over MySQL is that the management's just a lot easier. It's just a database that happens to be there if you're doing simple queries. Just doing your gets and your puts out of it tends to be a lot simpler and easier and safer and more reliable than having to worry about some of the additional complexities of managing an actual SQL database. This is an example of what the front page might look like of Flipboard when you go into it. And you can see that in the lower left-hand corner, this is simply a picture that was shared from one of my friends. So the minute you launch the application, we've already surfaced a variety of articles and photos that have been shared with you through your social network into the product as soon as you get into it. In the upper right-hand corner is a preview of some of the more relevant stuff that has happened very recently that you might care about looking at. And you can click into there to essentially get more details within there. And it keeps going deeper and deeper. As you go into these articles, you'll learn more about, well, for each specific article, who's commenting on it, who's liking it, which of your friends care about it. And so all this information is being stored over in MySQL so that we can aggregate it very quickly and present it to the user. Some tips for RDS that we've learned in using it. The first one is that you should leverage the cloud for what the cloud is good at, which is elasticity. If you go into a cloud and you start taking some of your old mentality ways of building your own data center, managing subnets and routers and access control lists at the IP level, you're basically doing a lot of work that you don't need to, and you're wasting a lot of time. It is much better to just hop on the bandwagon and learn how to implement the security and networking mechanisms that give you that ability to quickly expand when you need to be able to expand. And then leverage that in your application. Don't confine yourself to doing really complex designs, limiting what you can do when you find there's some new feature you wish you had and you could do quickly, but your model isn't going to support that. For scaling up with RDS, it's real simple. You start with a low-end database, you monitor it, you hit a button, you get a bigger one. There's really not much more to say about it than that. The amount of time it takes to go from a lower-end instance to a higher-end instance, we found is very quick and very easy to do. Another tip, I found that a 500 gigabyte database, just go with a larger size database because it tends to get a lot better I/O performance than if you start with a much smaller, say 32 gigabyte database, only because you only need a smaller one. The larger ones tend to have what seems to be much more reliable performance across the board. If you don't have complex data, you have real simple data, something other than, and you don't need to do SQL, something other than RDS would probably be a better solution. Even though RDS is managed, you still have to do stuff with it and manage it. You can run out of space. You can run out of performance, and you're going to have to deal with that. Other solutions out there that have sharding built in, for instance, like DynamoDB, where you don't have to worry about it, you get that for free. So if you don't actually need that mechanisms for querying the data, you don't necessarily want to go ahead and do that. Another little tip we learned was read and write I/O performance. If you have a large database, tens of millions of rows or whatever it is, and you do some queries that can be pretty harsh on it, read-wise, that will affect your ability to perform at scale write-wise. Likewise, doing, say, MapReduce jobs that will decide I want to blast 10,000 records into my SQL database to make them available to someone is also not a very good thing. That can cause things to kind of freeze up for a brief period of time. It's much better to spread those jobs out over some period of time to give it a little bit more of a breather. For the read operations, what we found is that if you find that your write I/O is being impacted quite often, it's because of an expensive read operation. We just go ahead and hit a button and create a read replica and then move those gnarly read operations off to the read replica, as long as it doesn't require that the data is 100% accurate up to date. You know, for instance, if you're looking to do a count of records, or if you're looking to get a general feel for certain data, but it doesn't have to be absolutely correct because the user needs to know that it's accurate 100% and able to modify it. And that's something that we've leveraged quite a bit. RDS is still SQL. You're not going to get around that. There's nothing that RDS is going to help you when it comes to optimizing your system for doing very well at SQL performance. You're still going to have to use all the same techniques and strategies that you use today to perform well within an SQL database. So you got to make sure you do your joins the right way and your indexes and everything is set up properly. One of the things that I really love about using RDS is they have daily snapshots, and they also have point and instant backups. But every night at a certain time we get a certain backup. And so from a development perspective, what I tend to do is I'll wake up the next day and I'll create a whole new database instance from a previous snapshot of real data, and I will test some new code I'm writing against that new snapshotted database instance. It allows me to actually operate on data that's pretty much close to real time with what our users are seeing without worrying about messing with the real data over in a separate sandbox. And this all happens without having to do MySQL dumps and other stuff yourself in order to make sure it all goes in there. It's all basically ready and available, and you can just kick it off, and then you have a new database to operate off of. And finally, the one thing I will mention is for RDS, you still have to worry about scaling horizontally. If you are going to have lots of users with lots of write IO operations, you're eventually going to be hit with the situation where the largest size database is not going to be good enough for you, and you're going to have to start building out more and more databases and pick which database you're going to go to for each operation. Typically what we've done or people do is to just shard based on the user ID, right? If you're a service based on users, you just figure out a hash based on your user, and then you pick the right database, and then you map them over to that. And so those are pretty much the tips that I have from our experiences over at Flipboard. Thank you.
That's an awesome presentation. I think a lot of things that I, especially when my wife goes through Flipboard on our iPad, she always says, "Is this the one that you guys are helping?" I said, "No, our part is really small. They are the innovators." So fantastic. Thanks, Greg. So there is always this debate to say yes to SQL or to say no to SQL. And we think that kind of a dialogue is not super effective. We think you as application architects, you as data owners, you as innovators have to have that choice. And you have to be able to make that choice based on a variety of trade-offs that are obvious to you, that you need to deliberate and you need to debate and figure it out. For example, it's not an exhaustive list, but you can certainly take a look at it and say, is my application an existing database application? Is this a business process-centric app where I have to go through a complex relational data model, workflow, process flow, and other things? In that case, you might want to stick with the relational model, RDS model, and then properly design it to scale up as well as scale out. As Greg was saying, clearly you'll have to take some matters in your hand, particularly the scale out part of it from a sharding perspective. On the other hand, if you are rethinking this application, you built it with existing technology 10 years ago, 5 years ago, now you want to be completely social, completely mobile, completely go to the new world, you might want to think about simplifying the data model, build it for web scale, and do a large number of small writes and reads, and your transactional semantics might be a lot simpler than what your relational model can provide. In that case, you might want to choose DynamoDB. In particular, if you want to think about scale, you might want to think about a very clear choice of, is this going to be architected by a DBA or an application, or does this need to be completely seamless and the system does the work for you? This is a very important conversation within your engineering team, your application development team. An equally important conversation is also the skill set that you have. At the end of the day, we are all racing to meet a particular market demand. Your users have patience, but only that much, which means you have to get new applications really fast. So you might want to take advantage of the skill set that you have. Going to a new model, such as DynamoDB, while it's going to give you a lot of benefits, may require you to augment your skills in the team. You need to know the web style of programming. Once you think about all of that and you choose to go through the scale, you can really think about how your application's requirement evolves. These days, given the mobile and social world that we live in, customer expectation is to have consistent, predictable, high performance. The older technologies can create a graph that looks like the red line. What that means is to catch up to the performance expectations your users have, you will have to be dealing with a lot of management issues on your own. That's why, as Werner was showing, go faster and faster on higher and higher scale, from scaling from an architecture perspective to scaling by demand. That's the model that we want to propose. And that really means Amazon DynamoDB from our perspective. Several years ago, I think it's like 6 or 7 years ago, when the DynamoDB team was responsible for building this for our company, they came up with a set of requirements that was codified in a paper, the original paper that we wrote. That's what we learned over the 7 years. We took the time to learn how to operate this as a service on our own nickel and dime. Now we are transitioning that and have launched it as a service that you can take advantage of. First and foremost, we designed with ease of administration in mind, which means for all the sharding and other scaling, you don't have to do anything. You just quite literally dial it up or dial it down. System manages itself. We designed for performance. We built it on latest state-of-the-art solid-state technology, so you get the best read-write capabilities. We also allow you to reserve the capacity that you need. That way, you don't have to worry about will you have the scale that you need. Last but not least is the throughput parts of it is really something you don't have to worry about. You can start with the smallest throughput application, scale it up completely on demand, and scale it down as you see fit. This is very different than the way you would have thought about managing databases. This is about providing fast, predictable performance. This is about providing seamless scalability. This is not about managing lots and lots of little databases from a fully sharded perspective. Most importantly, this is all about simplifying the administration of the database. This is actually something Matt Wood shared with the developer summit that we had yesterday. What we are showing you here is what do we mean by high performance. On one axis, particularly this, as you can see, the CPU performance is been going up and down. This is how intensive the processor is working. On the other hand, you can see the get latency, which is shown as pretty much like a flat line. That's what the DynamoDB database performance is. So when you juxtapose your CPU, how intensely it's working, versus your I/O performance, which is really, really rock solid, stable, and very millisecond performance, single-digit millisecond performance, you can really see how your application is going to perform super optimally for your users. This model is also very different than how you typically buy databases. Here, just like the way you buy your cable company channels, or you buy electricity, or you buy cell phone plans, here you reserve the throughput that you want. You set a table creation. You can programmatically change it via API call. You just pay a penny for every 10 units of write, or a penny for every 50 units of read. Very simple, straightforward model. All programmers know the size of the objects that you are reading or writing, reading from or writing to, and it's very straightforward to calculate what the cost of your operation would be. You don't need to worry about small instance, large instance, extra large instance. You don't need to think about input, output, all of that things. It's a very straightforward model from a performance perspective. Once again, since we launched this technology in January, we have seen unbelievable adoption. We literally have thousands of users using this. DynamoDB has been one of the most fastest growing from an adoption perspective within the AWS services. To hear a first-hand experience of an incredibly cool application, I'd like to invite the Earth Networks team. They have built an awesome, awesome application. Come on in.
Thank you.
Yeah, you're welcome. Eddie, thank you.
Can you hear me okay? Good afternoon. We're Earth Networks. I'm Eric Weller, Director of Development with Edward Dingles. He's the technical lead for the DynamoDB implementation. I'm going to do the first couple slides to give a brief overview, and then Edward will come up and take over the technical analysis and the technical solution. Who is Earth Networks? Earth Networks owns and operates the largest weather network in the world. It's about 5 to 6 times larger than the National Weather Service. The data that we gather on this network, we store, we analyze, we provide it to consumers, to governments, to scientists, so that they can get a better understanding of what's going on with the planet. We also have our newest productized sensor network, which is for lightning. That output is used to pinpoint lightning strikes. It's also the best indicator of when there's dangerous weather in the area. We also are the owner of the WeatherBug brand of products that you can get all this data from, as well as we have over 30 million users on these products. So our problem. Our CEO, probably a lot of you have your CEO or someone high up come to you and give you a nice challenge. So our CEO comes to us, and he's a founder of the company as well, comes to us and basically asks us, how can we get this great lightning data? And you know, I'm outside a lot. I'm outside with my family. I'm on athletic fields, playing golf, enjoying the weather. So how can I get this information that's relevant to me while I'm outside on my mobile device to provide safety to the consumer? And we had a lot of constraints. One of them was, how do we do this geospatially? We have this real-time lightning data coming in, as well as we have mobile users that are moving. So 2 dynamic data sets. So we had to do geospatial queries. It also had to be scalable. We have out of the box, we have 6 million users currently. We also have 100% year-over-year growth. And severe weather outbreaks drive high data rates and high usage from our consumers. It needed to be fast. Fast, speed plus accuracy equals safety. And we want our consumers of our products to feel safe. We also had a very short window of time, reduced time to market, and we needed to have a low cost of ownership. At this time, I'd like to welcome Edward to the podium. Thank you, Edward.
All right, so I'm going to kind of dive into the technical stuff. What I'd like to kind of do first is review. Fundamentally, we had a spatial problem here. So there's a set of lightning data that's real time, all right, spatially located, and we have a set of users. They're moving about in the world. And what we really want to do is take those 2 sets of data and sort of mash them together. For every user, we want to produce the closest and most relevant set of lightning data for them, and doing this all in real time. So when we came to this problem, what we decided to do was look at a 3-tiered architecture approach. We were going to have a front-end web tier, which we put behind ELB and use auto-scaling to meet user demand. What we'd have is a middle data tier, which we wanted to be consistent, durable, and highly available. And then a back-end management tier for loading the data and putting the data into whatever data tier we needed. So we kind of had the opportunity to look through a couple different data tiers, and that's what we want to focus on today. And one of the first things we looked at was SQL Server 2008, and really the spatial component here. So one of the things is SQL Spatial is pretty efficient at answering the spatial question and can scale out pretty well. But one of the things is there's a very high cost of ownership. You have to pay for licensing. You have to pay for administration. And you know, fundamentally, we wanted to constrain the problem and drive down the cost of ownership here. So we started looking at MySQL, which has a lower cost of ownership in terms of the licensing constraints, but a much higher cost of, still a high cost of ownership in terms of DBA administration. Also, I should note that fundamentally Earth Networks is a Microsoft shop. We do a lot of work with .NET and SQL Server. So MySQL wasn't really in our wheelhouse, which is why I have a high engineering cost here. Whereas with SQL Server Spatial, we're very familiar with it and have used it a lot for doing a number of different things. MySQL wasn't really sort of in our wheelhouse. So the other thing we've done a lot of, since we've worked with spatial data at Earth Networks a lot, is we have a number of in-memory structures we use, quad trees, KD trees, for doing spatial analysis. Now, these in-memory structures are very good. They have a very high throughput for spatial queries. However, the engineering cost is very high, since these are all custom-rolled applications. The good news here is the cost of ownership is a little less. All we would really be paying for is the Amazon EC2 instances. We can scale these instances out using either auto-scaling and place them behind ELBs. So the management there is a little bit easier in terms of the instances. However, we ourselves need to maintain consistency at the data level, right? So with SQL Server, we have different options for maintaining consistency, whether we're looking at clustering or sharding or things like these. But with custom solutions, we would have to build all the logic to maintain consistency between these instances. About a year ago, our company started moving all of our physical data centers into Amazon. And so far, we've closed actually 4 physical data centers. And so what we started to do was look at some Amazon technologies here to possibly help us with this problem. And one of the pieces we looked at was Memcache. Now, Memcache was fairly good and was very highly efficient at answering part of the spatial query for us. In terms of development, it was very easy to work with, but we still had to manage the instances. And when we got this problem, DynamoDB had just come out about a month earlier. And we started working with it, and literally on the first day, we were able to provision it, get it up and running, and start working with it. The throughput of it is just as high as Memcache, or relatively as high as our in-memory structures. But the engineering cost of working with it is extremely low. Also, the cost of ownership here is very low from an administration perspective and the ability to just scale it out. So now I kind of want to go into the solution we did using Dynamo. And one of the things here was we had spatially located data, right? It's latitude and longitude. But DynamoDB is a key-valued database. And really, you have the option of using a hash key and a range key. And so what we decided to do is we would geohash our lightning data. And what this is, it's a way of taking a latitude and longitude and reducing it to a single value. And fundamentally, what this does is create buckets inside of Dynamo. So what we did is we have our backend services, which are constantly taking in this real-time stream of lightning data, geohashing it, and creating basically localized buckets inside of Dynamo. We also have the front-end web service, which I talked about before, for encoding and decoding the data. What's interesting there is even with the efficiency of Dynamo and being able to query back very efficiently a subset of the lightning data, we still found that doing greater circle distance calculations were too expensive. And so we further optimized our front-end web tier to use geometric instead of trigonometric calculations. And what this fundamentally meant is we could support a higher throughput even in our web side. Now, we didn't want to lose accuracy. So what we're doing is we're actually sending back a set of data to the client. The client will compute the actual ranges and then produce alerts. So kind of our reflection on our DynamoDB usage. One, it's extremely easy to provision. Compare it to SQL Server, where you're going to have to go out and buy licenses, get instances set up, do the installation yourself. There's no contest. It's just that much easier to provision. Furthermore, it has built-in consistency. So when you talk about things like Memcache and having to maintain consistency between instances, this is not an issue with Dynamo. Basically, you're going to have a consistency within a region. It's highly scalable. So in terms of needing to meet on-demand load, all you have to do is edit your read-write counts, and you can increase to pretty much an arbitrary limit. Also, it's highly available. So take your any other solution. Within a region, you may have to handle high availability on yourself. Whether it's with RDS or whether it's with any other system, you're going to have to handle your high availability. Now, there are still a couple things we wanted to see from Dynamo, and I'm sure they're still working on it. But one thing we'd like to see is automated region, basically disaster recovery failover. So right now, Dynamo is located within a region, not across regions. So the other thing we could ask for is durability across regions, so that DB could be defined in multiple regions. We'd like to be able to auto-scale down without a throttle. So right now, you can auto-scale up as quickly as you want. And this is actually very important for us. For example, as Eric was talking about, population centers with storms will drive very high throughput. So for example, storms in New York City will drive throughput user queries up very high. But right now, in terms of auto-scaling, you can go up as much as you want, but down only once every 24 hours. What would be nice is if we could auto-scale down relatively as quickly as we could auto-scale up in terms of saving on money. Also, there's an item size limit of 64K. Now, this is a fairly large limit, much bigger than simple DB, and there are ways to work around it, but any increase on this size would be helpful for us. So what I'd like to do now is kind of show a little demo here of the application working. And what you're going to see here, kind of before I hit play, is here was an actual storm that happened last weekend over in Indianapolis. And here you have radar overlaid with our real-time lightning data. On the right side is our iPhone application. The rings represent 10, 20, and 30 miles. So let's see if we can get this playing. So the lightning's coming in. It passes the 30 miles. All of a sudden, right under the sun, well, you're getting this. As it's moving in, you're getting more alerts, basically telling you to be cautious. Now it's right over top of you, and it's basically telling you, seek shelter now. So that's the application we built. And we had a great time with it.
Just for kicks, I'm going to play it again. It is just unreal. I mean, let's see if I can get the mouse. There it is. Here it is, lightning coming in, 30 miles, 22 miles, 13 miles, 0. Take cover. It's pretty neat, pretty neat. Nice job, guys. So with that, I wanted to open it up for any questions. I think there is, I might also ask Greg and Eddie, you guys to come over, just in case the questions are for you. So come on over. You can also come. Yeah. Okay. We also wanted to mention, as you are getting ready for questions, that you can use Amazon RDS and DynamoDB for free. Go to aws.amazon.com/RDS for RDS free trial, and then DynamoDB for DynamoDB free trial.
Now that 64 limit, is that like the kind of like an insert into SQL type thing? And using how does that 64?
Go ahead, I'll let you answer. Yeah, actually, you know the answer.
So that's the item size limit. So basically, a single item in Dynamo referenced by a key has a limit of 64K. There are ways around that. So one of the suggestions from Amazon is store larger objects on S3. The other thing we've done is we'll have a single key, which can be compounds. So there's the hash key as well as the range key. And what we're actually doing here in the Lightning solution, because Lightning can be concentrated, we're using overflow buckets. So the geohash key may exist, the hash key may exist multiple times, but we use a range key as a bucket indicator. So basically, there are ways around it. You can organize your data in there. You can use time slicing. There's a number of different options we're using for different data types.
Thank you.
But you can think of that as like a size of a row.
Yeah.
Yeah.
In your example, you said that the database query came back with all the lightning strikes, and then the client did actual distance computations. Yep. How did you trade that off? How did you optimize that? And about how many lightning strikes would be sent to the client for it to sort through?
Okay. So two pieces. One, we actually optimized it at 2 levels. From Dynamo, we got a subset of the total global lightning data, and that was based on a configurable region within the client based on safety. So about 30 miles is what we're looking at. What the front-end web tier would actually do is use geometric calculations to prune that down to an approximate set, normally between, say, 10 and 20 strikes. And to get into sort of the math behind it, the error rates for using geometric calculations rather than greater circle distance calculations within less than 30 miles is very small. So there's ways around it. So basically, I think to answer your question, about 10 to 20 strikes go to the client to actually compute, because all we're really concerned here with is the closest strike on the client for the alert.
During your development process, what did you use to stand in for DynamoDB? Do you have some kind of mocking framework?
Okay, so that's interesting. We actually implemented all the solutions you see above, as well as another in-memory solution. So one of the things that was interesting here is this was our first experience with Dynamo, so we actually had no idea how it would perform. And so within both our back-end data management as well as our web tier, we built adapters for pretty much every one of these frameworks and implemented across each data tier, and then basically tested them. So you can do stand-ins for Dynamo, whether it's in memory, whether it's SQL, whether it's MySQL. I mean, all Dynamo is key value based. So you can even set up SQL tables that are key value based, put adapters on both ends, and work with SQL.
You had a question about using RDS read replicas. I was thinking about this for my application, and I wonder what the latency is as far as, let's say my application writes something and then a millisecond later something else decides to read it. I'm expecting I might get consistency problems.
Well, our experience, I haven't needed to get sub-millisecond accuracy in terms of updates. We've only used the read replicas for doing operations which you didn't need absolute guarantees on the data. But from what I've seen, it's been pretty quick in terms of the replication. I've never seen any delays.
So the read replica uses the native MySQL replication. So it's not the same as the multi-AZ synchronous replication that we do. I don't want to say this is asynchronous, but it is possible given the MySQL concurrency issues that sometimes this might actually there might be a lag. So you really need to take that into account from an application perspective.
I was just curious for the differences between your geohashing method in the DynamoDB versus, say, the geospatial querying in SQL. Have you noticed any differences between accuracy or performance? Have you done any cinnamon testings with the differences? Or?
In terms of using single key lookups inside of SQL versus single key lookups inside of Dynamo, is that what you're asking?
No, I'm talking about geospatial querying using SQL versus geohashing using DynamoDB.
So in SQL, there's not geohashing, right? It's actually a geotype, right? And you're storing it. You can highly index the tables, but what we found is with Dynamo, at least in this particular case for this set of data, Dynamo is going to outperform SQL. Now, the thing here is we're dealing with two sets of point data, right? So we couldn't have done this solution if we were dealing with point to polygon or polygon to polygon solution. So there are reasons to stick with SQL Spatial rather than Dynamo. In terms of an actual analysis, yeah, I mean, really, we found Dynamo is going to be much more scalable for point to point.
Okay, thank you.
So we are completely out of time. What I wanted to say is I don't want to avoid the questions. Maybe we take them right in the back. If you guys are okay with that, my apologies. So thank you so much for everyone's time.